Okay, the next section we're going into is exponential functions. And when we talk about exponential functions, we need to understand the properties that are involved. Okay, so when we look at an exponential function, it's going to look like this. Y equals a times b to the x power. This is general form. And the a value is our starting value, which is usually the y-intercept when it's in this form. And the b value is our growth factor. Okay. So that's what the general form looks like. So if we had y equals 2 times 3 to the x power, that would mean that our graph starts at 2 on the y-axis, and it's growing pretty quickly at a rate of 3. And remember, the property of exponentials is that it tails off to the end with an with an asymptote. Okay, now this gets complicated because this is the y-intercept when it's in this form. But what would happen if I added 3 to the graph? So think about what you've done with quadratics. What happens to the graph when we add 3 to the end? It shifts it straight up 3. So notice that our y-intercept starts at 2, but now we're shifting it up 3. So in this case, our y-intercept now is really 5, and then it does the same curving behavior. So if you have a question like this and I ask you what the y-intercept is, you have to take into account this number and this value. Okay. All right, so write an exponential equation given a table of values. Okay, so that would look like this. Okay, so when we have a table of values, and I'm going to try to make it up real quick on my own. So let's say that it's 500, and then it's 100, and then it's 20. Okay. So being an exponential equation, exponential means that we are constantly multiplying by something. So to figure this out, you take any term and you divide it by the term in front of it. And we keep doing that. So I'm going to take 20 and dividing it by the term in front of it. When you continually do this, you will see that you get the same value, and that is your R value or your growth factor. Okay, so that means our exponential equation is going to look something like this. Y equals 0.2 to the x power. Now, what's missing is we have to find the y-intercept. Well, remember the y-intercept is when x is 0. So we know when x is 1, so we have to go backwards one more time. So to move down this table, 500 times 0.2 is 100, times 0.2 is 20. So to go backwards, instead of timesing by 0.2, we are going to divide. So I'm going to take 500 and divide it by 0.2, and that gives us our y-intercept. So our y-intercept happens at 2,500. Okay. All right. You will be given a scenario like our population growth. We did uptown and downtown, 2 different towns. And you have to, by looking at the scenario, decide, is it exponential growth or is it exponential decay? And the way you do that is by looking at this number. If this number is greater than 1, it's growth. And the growth factor is, the 1 means it's staying the same. The growth factor is whatever 0.05 is as a percent. So this is representing 5% growth every year. If this number is less than 1, it's a decay scenario. And the way we figure out how much it decays by is we think about this number is going to be a 1 or 100% if it's staying the same, but it's 98% stays the same. So that means we have a 2% decline in population every year. Okay. All right. Quadratic functions. You're going to have a maximizing garden problem. Okay. So we have a backyard that is 50 feet long. We plan to put 2 square sheds on each side of the backyard. And they're square, meaning that these dimensions are x by x. And we want to calculate how much grass area do we have in the backyard between these 2 sheds. Okay? So if this whole thing is 50, this grassy area is going to have a length right here of 50 minus 2x. The whole thing's 50. I'm going to take away x and take away another x. And the grassy area has a width of x. So the area formula for this rectangle is length times width. So we do this. Then you graph this, and this is going to be a quadratic. And to find the maximum area, you find the point up here. And I have not done this, so let's just say that the maximum point comes out to be 15, 350. I just made those numbers up. In this scenario, x is 15, so that means if we put a 15 by 15 square shed on the left and on the right, so if this is a 15-foot shed on each side, that means that our grassy area is going to have 350 square feet of area. And that is the most grassy area possible. That's how you would interpret that. Okay, the next part, still have a lot of people that get confused on this. When you deal with a quadratic, let's say that this vertex point is at the point 2, 10. To find the interval of increase, you first have to locate what portion of the graph is increasing. So as you move left or right, it's going upward. But the interval is the x values that this produces. So this chunk of the graph is produced with the x values of negative infinity all the way up to 2. So our interval of increase is going to be from negative infinity all the way up to 2. Our interval of decrease is going to be from 2 all the way to the right. So we say from 2 all the way to positive infinity. Okay, the range of the function, using this example here, the range are the y values. So notice that this graph, the highest y value that it's going to hit is 10. But then it's going to hit 9.5, 8, all the way down to negative infinity. So we can say the range is all y values less than or equal to 10. Or we can say our range is everything from negative infinity all the way up to 10. You could write it in two ways, except we do want to include 10 this time, so we're going to do a square bracket. Okay, I'm going to go on with this same example. Let's say that this graph hits the x-intercept at negative 3, 0 and at positive 6, 0. So those are the two x-intercepts. If you are shown a graph, you need to find the factors. So if this is what you see, that means that one factor is going to be whatever produces a 0 at 6. So that's x minus 6. The other factor is x plus 3. So in this question, I'm not asking you to write the whole equations. I'm just saying find the factors. So those are the two factors. Okay, this is study guide part 2.